Hi guys, today what we're looking at is exercise 908 and we're going to look at questions 1 to question 5 in this video. So the first question says copy and complete the following tables by comparing the values obtained with the given graphs. Find which of the graphs A to C would result from plotting each set of points. So you have to do all 3 parts of this question. So I'm going to do part A for you and then you can have a go at doing B and C yourself. So you should copy this table down and then what we're going to do is we're going to substitute in our x value of minus 3 into our equation where our x is. So what this will look like, on your calculator you will write y equals, you'll do brackets, you'll put your x value of minus 3 in, hit the squared button and then plus 1. It is very important to do the brackets, otherwise you'll not get the correct answer. So when we go bracket minus 3 squared plus 1, I get the answer of 10. We're then going to go y equals minus 2 brackets squared plus 1 to get our next value. We get 5. Our next one we do bracket minus 1 squared plus 1 to get 2. We go bracket 0 squared plus 1 to get the value of 1. Next one we go bracket 1 squared plus 1 to get the value of 2. And then we go bracket 2 squared plus 1 to get the value of 5. And then we get bracket 3 squared plus 1 to get the value of 10. Now you will notice here that our negative x and our positive x have the same y value. So there's symmetry about this. Now what we want to do is we want to match up our points. So if I was to look at my first graph A here, if I go across to minus 3 and up to 10, oh yes, that is a point. I'm going to do a highlighter. So that is a point, yes. Then we have the next one, minus 2, 5. Oh, that's not quite a point there. So I don't think this is going to be the one that matches up. And then we have minus 1, 2. So that would be there, but it's meant to be there. So that means that A is not the correct graph for A. If we now look at B, we have the point minus 3, 10. Yes, that is a point. Then we have the point minus 2, 5. Oh, yes, this is looking good. Then we have minus 1, 2. Yes. And then we have 0, 1. Yes, we have 1, 2, 2, 5, and 3, 10. So that means that therefore A matches up with B. So on graph A, I'm going to write the equation y equals x squared plus 1. So that means that equation A is graph B. So now you'll have a go at doing B and C. So for B, you will sub in your values, but instead of plus 1, this time you'll have minus 1. And do not forget your brackets. So do not forget your brackets on the calculator. Okay, question 2. We want to complete a table of values ranging from x equals minus 3 to x equals 2 for the parabola of y equals x squared minus 2 and use the values obtained to graph the equation. So what I'm going to do is, I'm going to just add a page. And so this is exercise 908, question 2, and we wanted to draw a table. Going to be quite a long table, I think. I think this will be, we'll just do it like this. Okay, so this, we still need another line going like this. So this is our x value and our y value, and we're doing x values from minus 3. Oh, perfect. All the way up to 3, like so. So this is what your table should look like. And we're doing it for the equation. Let me just go back to the question and check. Y equals x squared minus 1. So we have the equation y equals x squared minus 1. Now, I'm not going to do this whole table for you because it's important that you do it yourself. But for our first x value, x equals minus 3, what we're going to do is we're going to put it into our calculator so that we get y equals don't forget your brackets, minus 3 squared. Hang on, is this the right equation? Oh, that should be a minus 2. Minus 2, sorry. And minus 2. So in your calculator, you are going to go bracket minus 3, close your bracket, squared, minus 2, and you get the value of 7. So we'll put a 7 in here. Then for x equals minus 2, you do the same. So you go y equals bracket minus 2 squared minus 2 equals, and you'll get your answer. Then for x equals minus 1, you go y equals minus 1 squared minus 2 equals, and you'll get your answer, and you'll put it in your box. Okay, I'm not going to do the whole thing for you, but that is what you should do, and do not forget your brackets. Okay, question 3. We have what are the coordinates of the vertex for each of the parabola in question 1. So I'm just going to do this first parabola here in question 1. So, which is this one here. So the vertex is the point at, it's where, like, it's the point of the parabola, the base of the parabola. So the vertex, that coordinate is the coordinate 0, 2. Okay, so that's for A, and then you would do B, and you'd also do C yourself. So is the vertex also the y-intercept of the parabola? So for A, remember I'm only doing A, you need to do B. Our y-intercept is whatever point runs on this line. And so for this one, our vertex, which is where our pink dot is, does intercept our y-axis. So it is yes for this case, and you will answer B and C. Are the parabolas symmetrical? So when it's something symmetrical, it means if I was to fold the parabola in half here, this bit here would lie on this bit here, which is the case. So for A, the answer is yes. And then for D, it says, does the vertex lie on the axis of symmetry? So my axis of symmetry is this line here. That's where I would fold my parabola, and that's where my vertex lies. So my answer for A is also yes. So you need to have a go at answering B and C for 3A, B, C, and D. Now for question 4, we're going to complete a table of values ranging from x equals minus 3 to x equals 3 for each of the following equations, and state which of the graphs, E, F, or G, would be obtained by plotting these points. So I'm going to quickly just go and steal this, copy, just so I don't have to draw up a table. Okay, and so for A, so this is 4A, and we have the equation y equals minus x squared. Okay, and I'll rub this out. So for y equals minus x squared, what we want to do in our calculator is we want to go y equals minus bracket our x value of minus 3. So we're going to press the minus bracket minus 3 squared, and we get an answer of -9. So we'll put that in our box. We then do our next value, so y equals minus bracket minus 2 squared. So that will equal minus bracket minus 2 squared, gives us an answer of -4. Then we have y equals minus bracket minus 1 squared, and that gives us an answer of -1. Then we have y equals minus bracket 0 squared. So minus bracket 0 squared, which just gives us an answer of 0 on our calculator. Then we'll do y equals minus bracket 1 squared, which gives us an answer of -1. Then we'll have y equals minus bracket 2 squared, which gives us an answer of -4. And then we have y equals minus bracket 3 squared, which gives us an answer of -9. So remember, do not forget those brackets. That's the one thing that I will stress. Now we need to work out which parabola matches, or which graph matches with our equation y equals minus x squared. So our first point on our table is -3, -9. So let's look at E first. We go across to -3, down to -9. Yep, that's a point. Then we have -2, 4, minus 4, yep, that's a point. Then we have minus 1, that's a point. 0, 0, we have 1 minus 1, we have 2 minus 4, and we have 3 minus 9. So that means that A is matching up with E. So on A, I'm just going to write the equation y equals minus x squared to match it up. So therefore A equals E. So you'll go ahead and do a table of values for B and a table of values for C and see which graph either F or G matches with B and which graph G or F matches with C. Finally, question 5, we want to write down the coordinates of the vertex for each of the parabolas in question 4. So I will do A. So if we look at A, oh sorry, it's E. If we look at E, our vertex is the point here. Oops. Is the point here. So it's where our parabola, it actually turns from increasing to decreasing. It's also called a stationary point, but we call it a vertex at the moment. So a vertex, it's at the point 0, 0. So I just need to change this over to an E, and that's at the point 0, 0. For part B, is the vertex also the y-intercept of the parabola? So if we look at our parabola, our y-axis is here and our vertex intercepts it. So for E, our answer is yes. So remember, you then do the same for F and G. So is the parabola symmetrical? So if it's symmetrical, it means that if we were to fold this, it would go over this, which is the case. So the answer is yes. So E is yes. You do the answers for F and G. And does the vertex lie on the axis of symmetry? So our vertex here does in fact lie on our axis of symmetry, because our axis of symmetry is the y-axis in this case. So our answer to E is also yes.